in particular next week, especially the notion of weak and strong as it might relate to something like this, where you're passing a pointer from yourself to some other object. But this is some of the magic that now happens underneath the hood because of that feature, arc. Previously, we would have had to free it eventually ourselves. Technically, there's an auto release pool that does this for us and automatically frees the memory eventually. All right, so let's take this up one more notch. I'm going to kind of whiz through this code just so that you don't feel that you're entirely dependent on this interface builder. Let me open up nonib.xcode project. And in this example, if I expand the files over here, notice that we again have main.m. And let me emphasize here, when in doubt, when reading someone's code for the first time, certainly lecture examples and even Apple's or others, I think it's helpful to start with main.m just to reassure yourself, OK, familiar, nothing there. Let me now follow the breadcrumbs and go to appdelegate. OK, now I'm going to go to appdelegate.h. Nothing new here. This looks like the example from a while ago. View controller pointer and a window pointer. Appdelegate.m. No, nothing interesting in here. Looks like the brains of the operation are indeed in the view controller. Let's look at the .h. OK, a little interesting here. Alert view did dismiss with button index go. OK, that's actually the same as before. Notice I'm being explicit, as someone asked earlier, with read write, even though that's the default. I could say read only. View controller.m. So here's the difference. And you can immediately see why I used interface builder at first. This is the code with which I've implemented things without a nib. Notice missing at top left is viewcontroller.nib. So I'm doing it sort of the real way, like without using a little drag and drop WYSIWYG tool. So the price you pay is that it's a pain in the ass. And so here's the number of lines of code I've written. And this is a bit of an exaggeration because I could have relied on some defaults for some of the properties you're about to see. But I included them just to make explicit what the code looks like for a lot of those Photoshop-like attribute settings that I was so pleasantly clicking and dragging on earlier. So load view, if we read the documentation, is a method that comes with the UI view controller class, from which I descend. And he is responsible for loading the graphics onto the screen if you're not using a nib file. So because we have no nib, I have to do everything manually. But it's pretty readable, and I've certainly commented it succinctly, but hopefully clearly. Create view. How do you create the view? How do you create that default rectangle on top of which we start putting all of the other objects? I do self.view. I allocate a UI view, and I initialize it with the frame, much like we did before. Slightly different application frame, but it's essentially boilerplate code from documentation that I learned from initially. And that just gives me that rectangle. Self.view.background color gets white color. That's how I make the background white. So we've seen something like that before. Now it gets a little annoying. I have to use the core graphics library. Recall that under frameworks, we had core graphics.framework. Well, it turns out all of these little buttons, even though they're kind of ovular, a little curvy, I mean, they're two-dimensional graphics. And they're from lines of code like this. I create a cgrect frame by calling cgrectMake. So the core graphics library, turns out, is all in C. So now we're using C code. This is not object-oriented code per se, though it's kind of commingled, as you can see in line 2 here with UI text field alloc. But let me wave my hand at some of these details. But to emphasize this, I looked at Xcode. I looked at Interface Builder from the previous example and just determined by looking at the little GUI settings that that text field was 20 pixels down, 20 pixels over, hence the 20, 20. I also looked at the settings, and it said that the size that I created by dragging and dropping the left and right happened to end up being 280 pixels. So I copied that, and it happened to be 31 pixels high by default. So I really just manually and arbitrarily came up with those values. Now I'm initializing the text field with a frame. So I have to somehow tell the UI text field where it belongs in the canvas that I'm painting with my lines of code. The rest of these lines here, auto capitalization type, auto correction type, these are just essentially properties that I'm setting to constants to turn on or off capitalization and other UI features like that. Things that I would have gotten by checking boxes earlier. And then placeholder, notice I get quote unquote name. And here now, here's where I implement those blue lines. It's a little cryptic, and it's OK if you're not wholly comfortable with this just yet, because using Interface Builder is totally fine. And frankly, I think it's the better way to learn initially. Self.textField, add target self, action selector go, for control events. OK, this is a mouthful, and this is not uncommon. In Apple, their constants are very, very, very long, and they're namespaced effectively by having common prefixes. So what's going on here? I am sending a message to the text field to add to it a pointer, a reference to myself, specifically telling it to call the go method, otherwise known as a selector, whenever what event happens. There's that did end on exit event. Recall that Interface Builder kind of dumbed it down and simplified it, made it look grammatically nice with spaces and whatnot. But the constant in code that represents the did end on exit event is expressed this way. And it's just a number underneath the hood. And it's a constant that I would only know by reading the documentation. So these lines of code here that wrap onto 2 lines, this is the equivalent of the blue line that I drew from my text field to my file's owner. All right. Add text field to view. So this line of code, add subview, is taking the text field, taking that default view that's white on the bottom, and putting one on top of the other. That's what adding subview does. It just adds an object on top like you're plopping things down on a transparency. And now this is actually very similar to before. The button I create by creating another rectangle. These numbers I figured out just by looking at what the size of my go button was in the previous example. Could have come up with any other numbers. Notice that I instantiate a UI button of type UI button type rounded rect. That's the rounded rectangle that I so easily dragged and dropped earlier. I set what's called the button's frame. So what's the rectangle in which this button is going to live? I then set the title here for UI state, UI control state normal. So buttons have different states. If you touch and hold, it becomes blue usually. That's a different state. Just the normal state is going to be that constant. And then here's how I drew the other blue line. When I dragged from when I dragged from the button to file's owner, this is how I implemented that other blue line. As for the rest of the code, thankfully, this is the same as before. This is the same as before. Everything else is the same. Now, there is one new feature here. These pragmas, these preprocessor directives, these are just kind of a fluffy feature, kind of nice. I haven't used this before, but notice there's a little set of breadcrumbs up here that tell me where I am. If I click on, let's see, the rightmost one here, notice that it's kind of organized. Actions, UI alert view delegate with the bold facing and whatnot. That's coming from this. That's coming from this. It is purely aesthetic, just to kind of keep your methods organized if you care to do that. It has no functional effect on your code. Questions? So in the upcoming project, Draft of Whose Spec is online, you'll be implementing a program, recall, named Evil Hangman. Evil Hangman is much like the normal Hangman, except that it's evil in the sense that it cheats. So whereas in normal Hangman, you might choose like a 6-letter word and give blank spaces for each of those letters, and the human has to guess E, or A, or C, or D, or whatever letters, and you gradually reveal those letters as the user guesses your word piece by piece. Evil Hangman's a little different in that, recall, if I guess E, even if the computer was thinking of a 6-letter word that had an E, well, now he's going to change his mind and choose any other word from the dictionary that doesn't have any E's. So he can say, sorry, no E's. If you then are kind of smart in a sort of Wheel of Fortune sense, you go with A, another common letter. The computer is going to figure out, let me find a word in the dictionary that doesn't have E's or A's, so I can say, nope, no E's or A's. So it's constantly dodging your guesses in this way. And it turns out that if you give the user a finite number of guesses, like 4 chances or 5 or some relatively small number, odds are they're not going to win the game, and they're going to feel like an idiot when they realize that the 6-letter word was something so obvious, but it just didn't happen to have the letters they chose. And that's because the computer isn't really changing its mind try after try. It just has a large dictionary of words, and it's constantly throwing words away based on your guesses until you effectively paint it into a corner. So you'll be implementing this in the form of a utility application, which is one of the templates that was provided by Xcode. It's nice in that it's more complex than any of these examples we've done thus far. And we'll see others next week as well as others in lab this week. But the template alone that comes with Xcode gives you this nice little effect. If I click this UI button that looks like a little information sign, notice I get a 2-sided UI. And this is nice because, as you'll see in the spec, you'll be challenged to implement your user interface, your UI views, in the front of this interface. But then there's going to be some settings on the back, some sliders, for instance, that allow you to change the word size to make the game easier or harder, and the number of guesses that the user has allowed. And then when you flip it back by calling done, you'll actually have a chance then to play that game again. This will be a chance to play with NS arrays, NS dictionaries potentially, some of the building blocks we talked about both this week and last, and we'll continue talking about next week, so that ultimately you will begin this process by filling in some of these blanks. And so what I would encourage you to do between now and Wednesday is to actually try to, one, go home, download the source code from tonight, and actually tinker with some of the examples, delete lines of code, see what breaks, and try to understand why. And I would also strongly encourage everyone to take at least one or two of tonight's examples, maybe nib 1, nib 2, and try to recreate it, even if you're kind of cheating by comparing your code against mine side by side, but go through the motions of like writing up the code, figuring out how we wired things together, because odds are it'll take you half an hour potentially because you'll miss some stupid little detail, but it's that just kind of muscle memory that you want to build up so that when you really want to do things that are of interest and sort of fun in terms of this kind of game, you won't get tripped up on some of those little nuances. And we'll spend more time on that in lab. We'll also do a walkthrough of sorts to get you comfortable with the spec, and we'll dive in much deeper next Monday as well. So I'll stick around for questions, but otherwise, why don't we call it a night? See you next week.